Hey, what's up, guys? So today, while we were gonna play some Fortnite, I was thinking I could teach you how to solve a systems of equations. So what you're gonna do first is you're gonna use the y value that you
Why can't we be friends? 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 I pay my money to the welfare line. I see you standing in it every time. Why can't we be friends? 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 The color of your skin don't matter to me. Pow! As long as we can live in harmony. Why can't we be friends? Why can't we be friends? Why can't we be friends?
Hey, what's up, guys? Welcome to another wonderful day of math class. Hope you guys are all chilling. You should be having a pillow at your back, slippers on your feet, hot chocolate, and your best pajamas on, because Mr. Card has to dress all fancy because I have to come to school. You guys are coming to school on Tuesday. Congratulations, our quarantine time is almost over. This is one of my favorite quotes. It's by Miss Oprah Winfrey. You aren't your past, but a probability of your future. And so, like, everything that you do in your life builds up towards what you can become one day and what you can accomplish this world. If you get good grades in chemistry in high school, that doesn't mean that you've changed the world yet, but it is one step on you creating a future cancer curing drug, right? Like, if you want to be an astronaut one day, the first step is to get in shape today. They're not going to send you up there if you have debt. If you're overweight and like can't run and all that stuff, right? So everything that you do either increases or decreases the probability of your future. And my goal is that you have any future, the highest probability of any future you want. So we've been talking about outliers. And here's kind of a cartoon, right? I have a data set, right? And I have my outlier. And what outliers do in science is they're actually really upsetting because they are uncharacteristic of the rest of the data. So if all of your data is on this nice little line and there's a point over here, why did that point occur? There has to be a reason, right? Either your entire data set is wrong and you just luckily picked all the points on the line, and it really is just all spread out, right? And there's a bunch more points over here that you don't know about. Or there's a specific reason for that one, right? Like if this was antibody resistance after the vaccine, right? How much antibodies you build up over time. And there's one over here. Maybe this person was on steroids or immunosuppressants, right? Maybe they didn't have a working immune system, and that's why they never built up a necessary amount of antibodies, right? And so the conclusion of that is most times in science we'll actually throw out data. So if there is an outlier point like this, you're not going to talk about that point. You're going to talk about your line and how close the rest of the data points are. In like a subsection, you'll be like, oh yeah, there's this one point that kind of ruined everything, and we just decided not to count it. The number of outliers is a test of how strong your data is. So if you just have one, that's not a big deal. But if you have like 5 or 10 over there, that's going to get much more significant on whether or not your data is actually accurate or you're just making stuff up. So moving on, how do we figure out what an outlier is? To do that, we are going to need to, first create our box and whisker plot. So in this set of data, the median point is right between 5 and 13. 5 plus 13 is 23 divided by 2 is 21 and a half. Or sorry, oh my God, 11 and a half, right? So 11.5 is our median. No, that's not right. 12. So we have 13 between the two divided by 2 gives us 6.5. It should be 11.5. Yeah, 11.5 is our median. Sorry about that. Sometimes I do things stupidly. And then we need to find our lower quartile range, which would be the middle number of these guys. And that is going to be between 1 and 2, right? There's 6 numbers, so 1.5 is our lower quartile. And up on the other end, we're going to go between 18 and 100. And that is going to land us right between 32 and 40. So our median on this side is going to be 36. So our interquartile range, our box, goes from 1.5 to 36. 36 minus 1.5 gives us our IQR. Our IQR is our interquartile range. So in this case, our IQR is 36 minus 1.5, or 34.5. IQR is 34.5, and that is important because it gives us a range of the data. To figure out if a number is an outlier, what you're going to do is you're going to multiply the interquartile range by 1.5. So 34.5 times 1.5 gives us a number I have to do on my calculator. So this is our interquartile range. 1.5 times 34.5, and that gives us a number of 51.75. Okay? And so what that means is that any number that is outside of 51.75 away from the median would be considered an outlier. So there are no numbers, right, that are 57.5 away from the median on that side. However, there is the 100 number over here that would be considered an outlier. 57, however, would fall within the range of 1.5 past the IQR. Okay? So let's look at that a little bit more graphically. You had your normal box plot, right? 25th, 50th percentile, etc. Your normal whiskers are going to be another 25% out. Oh my God, you can't see that at all. So we got our normal box, and then we have 1.5 out. That still doesn't really look any better. But hopefully the last discussion helped you understand that. What you're going to take is the range from the box, right? The highest point in the box to the lowest point in the box, multiply that by 1.5 and add it or subtract it to your median. You're going to add it to see if there are outliers that are higher. You're going to subtract it to see if there are outliers that are lower. Okay, let's see if there are any outliers in this data set. First, we find our median. It is 12. Mr. Curry picked a very easy one for himself. Our lower median is going to be between those two, which is 7.5. Our upper median would be between these two, which would be 17.5. Therefore, our interquartile range is from 7.5 to 17.5, or 10. And we're going to have to multiply that by 1.5, right? So our interquartile range times 1.5 will give us, if anything, is an outlier. So 15 plus or minus 12 will determine if there's an outlier. So if we add 15, right, goes all the way up to 27. 20 is before 27, so 20 is not an outlier. If we subtract 15, it goes all the way down to -3, and 7 is before -3, so 7 is also not an outlier. So just to recap, you find your interquartile range, multiply it by 1.5. If you add or subtract that from the median, and you have a point that is outside of that range, that would be considered an outlier. All right, we have a bunch of different types of data, right? And we have to be able to determine whether they have a certain pattern to them, like this graph would be skewed right, skewed middle, and skewed left. So it's pretty easy to tell whether a graph is skewed. All the points are on one side or the other, or they have points in two different categories. That should tell you something scientifically about your data set, right? If the majority of data points are over here in the far right, that means that that is the most common or the most probable data range. So let me know if you guys have any questions, and please at this time return to the live classroom.